Bismillahirrahmanirrahim. Assalamualaikum and hi. Okay, we continue from the previous video. In the previous video we already study ataupun saya dah explain the type of structure and juga macam mana kita nak buat structure idealization. Okay, so the next one is the structure stability and determinancy. Okay, so let's proceed with the stability. Okay, so every civil engineering structure must be stable. Okay, so for a structure to be stable, it must have or it must to be in a equilibrium, or usually terms as a statically equilibrium. Okay, equilibrium ni maksudnya apa? Seimbang ke? Okay, so this is the example of unstable structure. Okay, for this one, kalau kita tengok dia ada this structure ada cable kat sini. So this one is roller, and this one also roller. Okay, so ada satu direction, dua direction yang ketiga. Okay, lepas tu ada kabel yang di type pada O. Okay, disebabkan ada external load ni, external load ini tidak parallel dengan origin O, so it become a unstable. Okay, so another unstable is this one. So dia ada roller, so dia ada external load dalam bentuk sengit macam ni. So tak ada satu pun setiap support ini hanya ada satu direction yang ke atas. So it tends to move this structure. Okay, so this unstable condition can be overcome if one of the support can change to the pin support. Okay, maksudnya kat sini kalau kita ubah salah satu daripada support ini menjadi pin support, dia akan ada dua reaction. So this structure will become more stable. Okay, alright, for the determinancy of the structure. Okay, a stable statically determined structure is a structure that does not move, tidak bergerak, ataupun become a mechanism under load. Jadi dia terinfluence setelah dikenakan load. Okay, and must comply with the equilibrium condition. Okay, the equilibrium condition or equation is when the sum of all forces and moment in a system where the x, y or z, which is the three-dimensional structure, must be equal to 0. So dalam bentuk mathematically kita boleh tulis sebagai summation fx equal to 0, summation fy equal to 0, summation fz equal to 0, and also summation of moment in all direction is equal to 0. So this is the equation, or this is the equilibrium condition or equation. Okay, so let's see the first example. Alright, this one. If the unknown reaction of a structure under the load can be computed or solved by using this equation, so the structure is termed as the statically determinate structure. So maksudnya kalau kita boleh selesaikan menggunakan this all equation of equilibrium, so that structure become a statically determinate structure. Okay, so let's see the first example. So determine the reaction unknown forces at the support of the structure shown below. So this is the structure. So we need to idealize the structure. So kita dah nampak sini ada beam. Okay, sini ada beam dan ini ada juga kita panggil beam, supported beam. Okay, so maksudnya dekat sini akan ada load. Okay, so di sini beam hanya diletakkan atas ini support. So dia menjadi roller, which is satu je reaction. Okay, so they call as this one A, this one is B. So AY, A dengan BY. So ada load. Figure ni dia tak tunjuk daripada atas berapa load ni. So setiap beam yang supporting beam ni ada load masing-masing dan juga diberi distance. So we need to solve this one in order to determine the reaction. Maksudnya kita kena selesaikan lah macam mana nak cari reaction dekat AY dan juga BY by using the equilibrium condition. So kita buatlah summation. Kalau kat sini saya assume semua dah tahulah ni ya, macam mana nak kira moment. Summation of moment at B is equal to 0. Okay, so kat sini bila dikata take moment at B is equal to 0 dan positif mengikut arah jam. Okay, so AY times dengan dia punya distance 3.6. Okay, AY times dengan distance 3.6. Then AY ni ikut arah jam. Okay, so tapi yang load yang lain ini, external load ini adalah melawan anti-clockwise. So it will come the negative. So the load times with the distance. Okay, then we can solve and we get the reaction at Y in Y direction. Then we can solve by using the summation of forces in Y direction is equal to 0. Then we get the reaction at B. Okay. Okay. In determining the statically determinate or statically indeterminate. Okay, tadi kita dah cakap statically determinate tu boleh disolvekan menggunakan equilibrium equation. Okay, so when the unknown forces exceed the number of equation equilibrium. Okay, so maksudnya number equilibrium dia, number of forces yang tak diketahui, kira reaction dia banyak, melebihi daripada number of equation of equilibrium. So this structure is stable, but then the structure is called as a statically indeterminate structure. Okay, in other words, the equation of equilibrium cannot solve the unknown forces by itself. Okay, so kita akan ada beberapa method yang kita nak solvekan sekiranya kita punya structure adalah indeterminate structure. But first of all, saya akan terang dulu macam mana kita nak bezakan statically determinate structure and also the statically indeterminate structure. Okay. Alright. Determinancy of beam and rigid frame. Okay. So there are three equations here. That will show whether the structure is statically determinate, statically indeterminate or unstable. Okay, so akan ada tengoklah dia fulfill which equation, which condition. Okay, R kat sini is represent the reaction. And here is represent the number of part in the system. Okay, so kita dah tahu roller hanya ada satu reaction, pin akan ada dua reaction, fixed support akan ada 3 reaction. Okay, so this is the maksud dia. R adalah external reaction, number of external reaction, and adalah number of part in the system. Okay, and the difference between R and 3N is called as a degree indeterminacy. Okay. Okay, let's see this example. Determinancy of beam. Okay, this is the beam. Okay, so determine whether the structure shows below are statically determinate, statically indeterminate, or unstable. Okay, so if it is statically indeterminate, determine the degree of indeterminacy. So kita dah tahu sini akan ada pin. Pin will have 2 reaction. Roller will have 1 reaction, and fixed will have 3 reaction. Okay. Okay, number of part or N dia. N kat sini akan jadi N sama dengan 1. N yang ni akan jadi, maksudnya ni N1, ni N2. So akan ada 2 N. Okay, so N is equal to 2. N is equal to, ni di call N1 and N2. So reaction, so tadi kita ada kat sini, at A we have pin, so pin will have 2 reaction. At B we have roller, so we will have 1 reaction. And at C we have the fixed support, we'll have the 3 reaction. So R summation 2 plus 1 plus 3 is equal 6. Okay, so dah tadi kita kata rumusnya adalah R sama dengan ataupun lebih besar atau lebih kecil daripada 3N. So kalau in this case R is 6 and 3N, 3 kali 2, 3 times 2 is equal 6. So it called as a statically determinate. Okay. For this case, okay, we have the, okay, how many parts? How many parts in this system? N1, N2, N3. So we'll have 3N. N is equal 3. So reaction at A, we have fixed here. So fixed have 3 reaction at A. So pin will have 2 reaction. Pin at C will have 2 reaction. And fixed at D will have 2 reaction. Okay, so fixed kat sini akan ada 3 reaction. Pin kat sini akan jadi 2 reaction. C pin 2 reaction. Dan juga fixed kat sini akan ada 3 reaction. Okay, so kita pecahkan dia. So kita kira dia punya summation of reaction. So total reaction dia adalah 2 campur 2, 3 campur 2 campur 2 campur 3. 3 plus 2 plus 2 plus 3 equal 10. N dia adalah 3. N equal to 3. So 3N is 3 times 3. So R here is greater than 3N. Okay, so it called as the statically determinate. And the difference between R and 3N we call as a degree indeterminacy. So here degree of indeterminacy is 1. Alright. So the last example here is this figure. So we see that this is the pin. Okay, at A we have pin, so pin akan ada 2 reaction. And at B, they consider as a pin also 2 reaction. 2 reaction. So R here is 2 plus 2 equal 4. Okay, and number of part here kita nampak 1 je. So dia tak ada pecah kat sini. So this is only 1 part. So N is equal 1. So R is 2 plus 2, 4. 3N adalah 3 times 1. So R is greater than 3N. We call as the statically indeterminate. Okay, so the degree of indeterminacy here is 4 minus 3 equal 1. 1 degree of indeterminacy. So that one is untuk beam. Belum lagi untuk rigid frame. Rigid frame sama juga, equation yang sama, cuma dia kena bahagikan. Okay. So this part will separate by 2. So reaction kat sini akan ada fix, yang sini akan ada pin. So N dia akan bahagi kepada 2. So bila dia pecah kedua dekat C and D, the reaction dekat tengah-tengah ni akan jadi 3, RD akan jadi 3. So R kat sini dia timeskan, dia tambahkan RA, RB, RC and RD. Sama juga untuk determinasi, degree of determinasi, just perbezaan antara Rn, 3n and R. Alright.